Ah, está Pedro Serrano, qué bueno. Perfecto.
Estamos vivos. Hola, Valentina.
Hola, hola. Hello, everyone. Diego, dime si ya comenzamos. Let me know if we can get started.
Just 5 minutes, please.
5 minutes, okay.
Okay.
¿Cómo? Apaga la música. ¿Puedes apagar?
¿Hay algún rebote en el sonido?
Mantengan los micrófonos apagados todos.
¿Ahí cómo me escuchan? ¿Se escucha bien?
Sí, perfecto. Ahí no hay rebote.
Perfecto. Bueno, me voy a poner para que todos me puedan ver acá. Aquí estamos. Okay, so anyone that no, I think that's people that don't speak Spanish, so we will need to make this event in English as it was planned. So welcome everyone. I'm Felipe Repeto, the Pavilion Director of the Chile Pavilion. Welcome to the Pavilion, Chile Pavilion. For those who are here with us, and for those who are joining us from other parts of the world, I think most of them are in Chile. Be welcome to this event. We'll have different presentations from ACHIDE, the Chilean Association for Space. So I will first would like to give the floor to Mrs. Loreto Moraga for an introduction and then the presentation of the different speakers. Thank you.
Thank you very much. Good morning, good afternoon, good evening, anywhere in the world you are connected to this event. We are the Chilean Space Association. We are a non-profit entity in Chile. Our members are professional and students related to the space. They are studying something related to the space or have experience working in something related to the space. Our goal is to promote and develop the space activities in Chile. And one of our projects had been working with the Moon Village Association, with a program. Its name is Space Emerging or Emerging Space Countries Program, PESC, because we are a Latin American country, had been some steps behind of this world of business space activities. And we don't want anymore to be behind. We want to be ahead now. We want to be a leader in the region. That is our expectation. We are decided to now not be anymore a witness, but to be part of this new kind of activities and economy. So let's get started. We are delayed, but now we are online. We are on a streaming by YouTube. So we expect to have an audience here connecting with us, learning about what is going on in Chile, what kind of ideas and projects we are developing here. So first of all, we are going to watch a video, a short video with a short presentation of each of 6 projects. We have more than that, but these 6 projects are going to be presented today. First we're going to watch the video, and then we're going to leave the floor to each of the teams to introduce themselves, to present their projects. And after that, we are going to have a little conversation with all the queries and comments that you may have in relation to those projects. So you are very welcome to this activity. We are very, very excited because this is our first experience in an international fair webinar in this kind of hybrid connection with the people in the conference room and here from Chile. So first of all, the video, Sebastián, please go on.
Thank you, Loreto.
Mm-hmm.
what if we could detect the first electromagnetic waves of the universe? What do we need? We need to get out of the Earth. We need to go to the moon. Some special location at the moon? Yes, at the lunar South Pole. Why there? Because at the lunar South Pole there are perpetually shadowed craters. We want to install a UVLF radio antennas inside of those craters you are seeing now. We have chosen a 20 kilometers diameter impact crater. Let us introduce you to the Shackleton's crater. At the left, image taken by United States NASA's LRO probe over the surface of the bottom of the crater by laser telemetry. The videos you saw previously were taken by Japanese Kaguya JAXA's probe in Selene mission. This is a 3D model of the Shackleton crater, a UVLF radio antenna concept with drive storage, data, and laser transmission capability. This is a papercraft model of a crater. At the surface of the bottom of the crater, there are several UVLF antennas to detect the redshift 21 cm hydrogen atom radio signal from the dark cosmic era of the universe. This is the first orbit of the lunar mothership. The second orbit of the lunar mothership deploys the antennas to the bottom of the crater. Now, the antennas are in the bottom of the Shackleton crater, in the shadowed area. This is the third orbit. The mothership catches the sunlight for stored electric energy and deploys that energy to the antennas by microwave cannons. The antennas store the energy and use it to upload the data collected by laser transmission in a subsequent pulse orbit. The mothership transmits the data to the Earth. This is a UVLF lunar project of Magellan Aerospace Industries from Punta Arenas, Chile.
Lunar Radio Telescope. Please, Mario, introduce yourself, introduce your team, and present your project. The floor is yours.
Thank you, Loreto. I will share a screen of a PowerPoint. My project is about a very low frequency radio antenna in the south pole of a lunar crater, a shadowy crater. And we have a team. I will share the presentation here that shows the people who are in this project. So, share presentation. Okay, vamos a share screen y vamos a ver si funciona. It's working. A ver.
It's working.
It's working? It's working? Okay.
Yes,
okay.
Please use the mode of presentation. Excellent.
Excellent, yeah. Well, this is the team. The team is, well, in the bottom of the screen, you are seeing now Francisco Arzúa Villegas from the right to the left. In the bottom photograph, Francisco Arzúa Villegas is a geographer. He's a specialist in GIS, geography in information system, and a specialist in other spatial matters. The other is Juan Almonacid Uribe. He's an astronomer in Punta Arenas, Chile. He observed the celestial body from Punta Arenas about 4 decades ago. The other is Eugenio Bahamonde. Sadly, he's not with us now. He was a space investigator. The other is me, Mario Esquivel Lizondo. I'm a lawyer, and I created the initiative Magellan Aerospace Industries. That our objective is to promote and divulgate space matters and space activities to our community in the Magellan administrative region of Chile and the Antarctic territory of Chile. As well, the guy in the photograph of up in the upside of the screen is Yuki Takahashi. Yuki Takahashi went to us in Punta Arenas when he installed a radio telescope in the south pole of the Earth in Antarctica in the base Atkinson Scott United States base. And he told us about this idea that he had about to install a very low frequency radio telescope in the far side of the moon, in the south pole, in a shadowy impact crater. Yeah. Another guy who support us is Yuri de la Barra. This not in the screen. He's a radio amateur and he's a member of the Chilean Air Force. Well, we propose, the objective of this proposal is to install radio antennas in the far side of the moon on the bottom of a perpetually shadowy impact crater at the south pole of the moon to detect the first electromagnetic radio wave of the universe that come from the dark cosmic age. The objective is to detect the first electromagnetic wave of the redshifted 21 centimeter hydrogen neutral atom radio signal from the dark age of the universe prior to reionization era. Why? Because the dark age of the universe is the only epoch of time that astronomy can detect the electromagnetic waves from around of the Earth or from space satellites. It's very difficult because the radio interference from the radiation of the sun and interference from the radiation of the man-made radio waves from the Earth at the bounds of those first electromagnetic long radio waves at the ionosphere layer of the Earth that acts like a shield. So it's very difficult to detect this first electromagnetic wave of the universe from the ground. It's very difficult. So if there are no stars in dark age, from where are born those electromagnetic waves? Because we want to detect these first electromagnetic waves, but where they come from? Well, very briefly, the electrons that rotate in the outermost orbit of the nucleus of the atom have a greater amount of energy than those that rotate closer to it. As the influence made by the attraction of the nucleus of the atom of those electrons in this case is weaker, those electrons are the most likely to leave their orbit. When some alien particle collides with one of these electrons in higher orbit motion, the electron becomes excited, causing it to leave its corresponding orbit and occupy for a brief moment another orbit of a higher energy level further away from the nucleus of the atom to which it belongs. The immediate reaction of the nucleus of the atom is to attract the electron to incorporate it back into its original orbit immediately in order to continue maintaining a neutral electrical balance. At this precise moment, the electron returns to its orbit the extra energy that was acquired by this electron when passing from a lower level to a higher energy level orbit and back to its original orbit, released in the form of a photon of light. The extra energy released with a photon of light. So, born an electromagnetic wave. The photon travels like an electromagnetic wave, and the electromagnetic waves are the fastest moving thing in the universe. They move at the speed of light because they are light, photons, 3,000 kilometers per second, but they 300,000 kilometers per second. But they have other properties too. Wavelength and frequency. Wavelength is the distance between two successive peaks or throws in the wave pattern. Frequency is the rate at which these peaks or flows move past at a specific point. Because the speed of light is fixed, high frequency wave must have short wavelength, and low frequency must have longer wavelength. Yeah. The Doppler effect and stretching of the wave. Thanks to spectroscopy, we can detect the motion of the stars, a phenomenon known as the Doppler effect, causes a slight shift in the color of starlight towards the blue or the red end of the continuous spectrum, depending on whether it is moving towards or away from us. Edwin Hubble discovered that many galaxies have absorption lines in the continuous spectrum to the red wavelength, discovering the stretching of the wave while travel on the space-time. So more distant galaxies further away, more faster than the nearest to the Earth. So a stretching of the dark era photon, where it goes from gamma wave and is beginning to radio wave at the end due to its loss of energy during the long journey from 13 billion light years of space to us. So the wave born like a gamma ray, but it's so many space and so many time that that's a wavelength stretching. Yeah. So come to us at the moon, in the Earth, like a long radio wave. Radio frequencies emitted by the luminance emitted prior to the creation of the star in the dark age of the universe. Very briefly, the 21 centimeter line, the hydrogen line, 20 centimeter line, or H1 line, is the electromagnetic radiation spectral line that is created by change in this energy state of neutral hydrogen atom. You know that a neutral hydrogen atom is only a proton with an electron orbit around him. This electromagnetic radiation has a precise frequency of 1,420 hertz, which is equivalent to the vacuum wavelength of 21 centimeters in free space. But the redshift that I told you before, this line will be observed at frequencies from 200 megahertz to about 9 megahertz on Earth. It potentially has two applications. The first, by mapping the intensity of redshift 21 centimeter radiation, it can, in principle, provide a very precise picture of the matter power spectrum in the period after recombination. Second, it can provide a picture of how the universe was reionized and as neutral hydrogen, which has been ionized by radiation from stars, from the first stars and the first galaxies, and the quasars will appear as whole in the 21 centimeter background. However, the 21 centimeters observation are very difficult. That was, I tell you before, difficult to make for ground-based experiments to observe the faint signal are plagued by interference from television transmitters and the ionosphere that I told you. So they must be made for very secluded, isolated sites with care taken to limit interference. And that isolated site is the permanently shadowy craters that are located in the south pole of the moon. The epoch to study is from the 300,000 years after the Big Bang until 1 billion years after the Big Bang, that the beginning of the reionization era when the first star and galaxy formed. But well, the Hubble telescope takes a far galaxy, very far galaxy from 400 million years after the Big Bang. But well, it's discussable. Several other projects how to make headway in this area in the near future, such as the precision array for probing for epoch of reionization paper, low frequency array LOFAR, Murchison wide field array MWA, Gian microwave radio telescope, mapper of the IGM spin temperature NIST, the Dark Age Radio Explorer DARE mission, and the Large Aperture Experiment to detect the Dark Age LIDAR. But these all are in the Earth, in the source of the Earth. That's the problem. So, the permanently shadowy regions, or PRS pole. This image was taken by our probe, and you can see this image and take it and download it by the NASA's Trek webpage. That's incredible page. That is very, very fun, very fun. And we detect and we know all the permanently shadowy regions in the South Pole that we can put a radio antenna in those areas. Yeah, as a shield, well, it's very useful as a shield against the sun radiation and earth radiation man-made object that I told you that they have radio quietness, VLF radio. as a platform for long interferometers area. Well, this is a picture that we taken from a video of Kaguya-JAXA Select mission of Japan, and you are seeing now the Shackleton crater that we choose. Yeah. This is the Shackleton crater taken by RRO probe of United States, and you are seeing now the shadow of the crater, the permanently shallow crater. The light of the sun never reached this area, never. But with a laser telemetry of the RRO probe, the laser telemetry takes the surface of the bottom of the Shackleton crater. In the picture you are seeing now at the left of the screen. Well, this is a shape file of 3D model of the Shackleton crater that we downloaded from the NASA Trek webpage. It's very useful. This is the old studies about Radio Lunar Observatory's proposal that study Yuki Takahashi. Yeah. Yuki Takahashi made a history registration about all the projects that astronomy project that want to put a lunar radio telescope in the South Pole. Well, the mission. Some expect data of a low-cost mission. This is we with the team we think about this. We know that it's very hard mission. It's very difficult, but we think that with a Proton rocket or Delta IV heavy rocket or GSLV Mark III rocket of India or Japan, we can put a first mothership with antennas for about 2,000 kilos with 100 kilometers lunar orbit altitude. Yeah. Well, this is the first option is to put an antenna rectenna proposal. Yeah. The second option is to put an antenna nuclear energy proposal. And the third option is an antenna with solar panels outer of crater or of the crater. Here you are seeing now a proposal of NASA of 2020. Yeah, it's really very rare, very strange, because when we interested in this project, immediately, well, I don't know why, but we know that NASA in 2020 had some proposal, JAXA too, the Russians too. So there is a little race in the south pole of the moon between in what is the radio astronomy and in water. Well, this is the mission. The first orbit, the lunar mothership, orbit around the moon, ¿no es cierto? Over the Shackleton crater. The lunar mothership, when reach a Shackleton crater in a subsequent orbit, in the second orbit, deploys the antenna to the bottom of the crater, like the video you saw previously. The antennas are made like an interferometer in the bottom of the crater. In the permanently shallow crater, they don't have interference from the sun horizontal light rays, and even of the man-made interference radio signals from Earth. Here, in other orbit, the mothership takes the sunlight with the solar panel to charge his batteries. And why? Because in another orbit, the lunar mothership beams the electricity by microwave cannon to the rechargeable battery that will be with the antenna to make functions the storage data, the laser uplink data, and other electronic systems. Yeah. Now, the antennas have a hard drive to store the data, to upload in the next orbit, pass of the mothership. Antennas have a rechargeable battery for laser uploading data to mothership in orbit. And in this time, the antennas laser uplink the data by laser, yeah, from the bottom of the crater to the mothership that acts like a relay satellite to send the data collected by the antennas to the Earth by radio waves. What are the problems? We know that it's a very ambitious proposal because many of these technology aren't developing in total development. For example, we know that the laser uplink data link only we have now 10 or 20 kilometers from point to point, we know that to beam electricity by microwave, like from a space-based power electricity system, is under development. Recently, last year, the Pentagon made some tests, but we hope that in recently time, this kind of technology will be more developed. But we have other problems. 3 problems. The first, the internal lunar satellite constellation. Soon, Starlink will have a Starlink constellation over the moon. So it's impossible to put a radio telescope in the south pole of the moon if we will have a Starlink constellation of satellites around the moon. Yeah. Other problem is the ice water in perpetually lunar shadowy crater in South Pole is a race. It's a geopolitical race that all superpowers and regional powers of space want to have this water ice reserve in the bottom of the crater. So we are thinking, well, where we go? So, well, there is Ceres, is a minor planet that have perpetually shadowy craters too. So this is the presentation. I hope that you understand, and thank you very much.
Thank you, Mario. Very complete presentation. Please download your presentation. Thank you very much. Carlos Palma, are you ready from the conference room in Dubai for your presentation?
Yes, well, I will try to.
Question, we may proceed. Well, first of all, we see here some questions. First for Mario Esquivel, if you are connected. A question: are you aware of other enterprises projecting the use of the same location? That's the first one. The second one, let me tell the 3 questions and then you answer in the order that you prefer. Yeah, okay. That was the first one. The second, other water reservoir near your location. And the third, do you think that ambient temperature range could be a problem? Please, we have 15 minutes for all the questions, so please focus and go directly to the answer.
Okay. Thank you, Loreto. Thank you, Rodrigo, for your questions. Yes, we are aware of other enterprises projecting in use the same location, especially well, India launched some years ago impact the Shackleton crater for to search water, but there is no really proof that there is water ice in the bottom of the Shackleton crater. Yeah. Our Prof of United States made también research about to found or search water beneath the surface of the moon too. But it no country has approved that there is really water or ice water on the moon. We must go there to find in situ in the area if there is water or not. But yes, we are aware that other enterprises projecting the use the same location. But we are fine because we know that there are at least 400 impact crater with shadow-weight permanently areas. So if Shackleton crater from 20 kilometers diameter will be used by another country or a lot of countries, well, we can move the project to another crater more small, no problem, but must be a permanently shadow-weight crater. We choose Shackleton because in Punta Arenas, Chile, all the members have some certainty with this historic person, because Shackleton was an Antarctic explorer, a British Antarctic explorer, who was rescued by Piloto Pardo, Navy Chilean captain, on 1916. So for that reason, we choose Shackleton because we have some certainty, some proximity to this person. Now, but with Are there water reservoirs near your location? Maybe it's possible that there is a water reservoirs near our location. In fact, on 2023, NASA will launch a rover to 40 miles from that location to search, for water. And do you think the ambient temperature range could be a problem? No, because in the permanently shadowy crater in the bottom, the temperature is constant. Because the shadow in the bottom of the crater is constant. Well, this is a very advantage to us because the other project of DUBAI frequency radio telescope project are in the surface of the moon. And the problem in the surface of the moon is that the temperature is not constant because, 14 days there is day and 14 days there is night. And between day and night, there is a margin of about 200 degrees from 173 minus degrees or below zero and 150 degrees over zero. So, but in the permanently shadowy crater, in the bottom of the crater, there is a constant temperature about minus 170 degrees Celsius, but it's constant. So it's a very advantage to put a radio telescope inside of those craters. Yep.
Okay, thank you.
Thank you so much.
Very complete answer. Now, Valentina, Pedro, your team. These questions are for architecture team. First question, what kind of rare earth are you expecting to exploit on the moon? Second question, are you aware of not to cause extreme damage to the lunar structure? Are you thinking in robotics, minery as a priority on dangerous environment planets?
Valentina.
I think this question is for Erin because she is working on the moon, but I think so. I'm working with the in there, so I'm searching for what for anything that are rare earth. I don't know if Erin can respond about the moon.
Okay, I continue. Yes, achieving architecture in moon is with low impact. Yeah? We think that all the structures can be deployed and undeployed from the moon without one step in the area. We are thinking many robotics mining in moon. No human moon with a cactus or like this. With rare earths are very little things. Yeah, we think rare earths are the target of this mining. Yeah, and it's not invasive. We are thinking the mining under the moon surface is another thing. Like Mario Esquivel size in this place, yeah, the temperature is constant. Yeah, we have not in this place cosmic radiation. We have not impact of meteorites. We have not a difference of temperature. By this, our experience in Chile in underground mining is very important for the underground mining. Oh, okay.
Good. We have the last two questions. This for the architecture group as well. Would you consider psychological support for travelers during this trip or stay? And the second one is, there are designated landing spots on Mars, or the ship will stay in Mars orbits?
Okay, I can respond. This is the principal thing, no? the psychological aspect is a principal thing of the architect point of view. Okay, we consider three or four things. First, artificial gravity. Yeah, it's not possible a trip for 2 or 3 years without gravity by the impact in the human body. Okay, the second is to respect the circadian cycles. Okay, the light in the day, the light in the night, our rhythmic way of life, no, like curriculums. The third is the color. All the design has color. The fourth is all the design has a picture from the Earth that for to be a live in the space with an connection with the Mother Earth. Okay. And the second question is very interesting. Our navies, our spaceships don't landing in Mars. No, it's a spaceship travel from Moon to Mars in the space, ever in the space. And from the ship, we have landing artifacts. What landing and go. It is necessary in the two positions, in Moon and Mars, to have gravity. You cannot stay in Mars 4 years or 3 years with the source of gravity of the Earth. You need gravity. It is necessary that the people go to the Navy to have gravity normal. Okay, that is.
Thank you very much, Pedro. Well, this is it. This is our first experience in an international webinar, hybrid system. Some people there in the Chilean pavilion in Dubai, some other here in Chile. We have been pleased to participate. Thank you very much to ProChile, to the Ministry of Foreign Affairs for the invitation to be part of this project of the Space Week in the Expo Dubai. So many thanks for all the audience that had been and stay connected in the Zoom platform and in YouTube. We know that some people is in YouTube watching us, so many thanks for them to be for a long time connected. We expect to have more webinars like this, and of course you are all invited for the fair that is going to be in April of next year, between the 5th and the 10th of April. That is FIDAE, the biggest air and space show in Latin America. So from us in my position of president of the Chilean Space Association, thank you very much, all of you. Thank you, ProChile. Thank you, Chilean authorities there. Thank you, the teams that have been doing their presentations. And well, you are invited to all next activities that we are going to organize in ACHIDE and of course in FIDAE. Thank you very much.
Thank you.
Bye-bye.
Bye-bye.
Okay, I invite you to see the position of 3D spaceships in the stand of Chile. Yeah, now it's there.
You're right, Pedro. People who are in Dubai, they bring some materials, an exhibition that we're going to be able to see there, some posters that are going to arrive soon as of to the pavilion. So you are cordially invited to visit the Chilean pavilion and see the exhibition. Thank you very, very much. Bye-bye.
Till tomorrow then. Thank you all. Bye.
Thank you. Bye-bye.
Thank you. Bye-bye. Stop the recording.